Hello and welcome to the Relearning for Inscribed Angles in Circles. If you are watching this at home, you're welcome to use your own paper to be able to put everything together and write down the answers that you need to do. If you would like to have the paper, it's in the back of room 1029 in the blue compartment all the way at the bottom because we're at the end of our school year putting this all together. All right, so we need to get some important terms in place. In here, we need the inscribed angles. Inscribed angle. So we're going to use this circle that we have over here as our example, but I'm going to give you it. Inscribed angle is an angle where the vertex, remember the vertex is where the two edges of our two lines of our angle come together at a point. So that's our point where they come together. And the end points are all on the circle. So we're looking specifically that we're looking at this. So if we had 3 points on here, and we'll just call them A, B, and C, we can make an angle. So all 3 points are directly related on to the circle. So this is angle B, A, C. Because remember, we need the vertex as our center point right here. This is our vertex. It's the point that's on the circle, and it's where the two legs of our angle come together. All right, an intercepted arc. An intercepted arc. So an arc always deals with the edge of the circle. So the intercepted arc is the arc inside the endpoints of the angle. In this case, it would be right here. It's where they intercept or cross the angle. Cross this, if we were to cut this cuts these right in half, or cuts this circle into sections. We're looking at this right here. This is not necessarily half, but nonetheless, this is an arc, is our intercepted arc. It's cut by the angle. So we're specifically looking at this angle right here, and we're cutting it with this. All right, it's always important for us because we can go back, and the central angle is so key to this chapter. I want you to remember what a central angle is. The central angle is an angle where the endpoints are on the circle, but the vertex is the center of the circle. So if we were to take a look at that, just using this right here, it would be that the center of the circle is our vertex, and these are our angles. So there's a very different topic that we're talking about. We're now moving that vertex from the center all the way to the edge. All the way to the edge. All right. An inscribed quadrilateral. Now, if you'll notice that inscribed means inside the circle. Inside the circle, so it's a four-sided figure because we have a quadrilateral, a four-sided figure drawn inside a circle. So if we have in here a circle, we just put our four-sided figure. It doesn't really matter how we do it, but we have all 4 points of our quadrilateral are inside our circle. All right, so here's some key information. Just like the central circle, the central angle, if you can remember from the standard that we covered directly before this is that the central angle, the angle measure, is equal to the arc measure. Well, this time it's different. We're going to take this angle measure, so we're going to shorten it, and it's 2 times the measure, and measure, recall, means that we need degrees of the angle equals the arc measure. Now this is for inscribed angles, inscribed angles. And I want to be clear about that because we just talked about central angles. But central angles are information that gets us to the inscribed angles. Inscribed angles are where all 3 vertex in here. So this arc measure is twice as big as our angle measure. It's twice as big. All right. There are a few bits that we can use in here that'll make this a little bit bigger, make this concept for inscribed angles bigger than just the arc properties that we have in here. We're looking at if we were having 2 inscribed angles. We have one right here, the yellow one, and then we have a red one here. So we have 2 angles. We find out that if 2 inscribed angles, all 3 vertex, the vertex and the 2 end points are all on the circle, if they share and arc. So right here, they share arc BD. They share arc BD in this case. The angles are the same. So now we can move that vertex around, but as long as the endpoints stay the same, we can see that this angle right here shares our, what we called in class, our ice cream. The cones are different, but yet because we have the same ice cream, we can say that the cones are exactly the same size, which means that our angles are the same size. So we can say that in here, angle BAD is equal to angle BCD. Again, endpoint, vertex, endpoint, endpoint, vertex, endpoint. Okay, so if we have a quadrilateral in here, a quadrilateral, we can say that the opposite sides are supplementary. Okay, so now we have 3 main facts. We have the formula for finding a basic inscribed angle. We have that the opposites, that the if they share an arc, they are the same. And now we're looking at our quadrilateral, which is our 4-sided figure drawn inside. So what does this mean? So we can look at this as angle D, which is right here, is plus the one directly across from it, angle B, is equal to 180 degrees. Same goes for here. So if we start at angle A plus angle C equals 180 degrees. So it's a little different than when we have a 3 points on here, 3 points. However, we can begin to figure these things out and put these things together if we have 4-sided. Okay. All right. I'm going to turn my page. So let's look at some practice problems. Practice problems. So in here, we have a bunch of angles. We have SRU, we have PRU, and we have PRS. So we have lots of different angles in here, and we have lots of different arcs. But some things don't change. One of the things that doesn't change is that the whole way around here is 360 degrees. We have no mention about diameters or anything like that at the center of the circle, so we can't use any of our terms from the central angles to put for information in here. So what are we looking at in here? So we need to find what is the measure. Measure tells us degrees of angle PRU. So we're looking at P, R, and U. So we should notice that the vertex of the angle is on the center of the circle. So we need to remember our formula. So when we pull our vertex down, this makes our arc very large. So our 2 times the angle equals the arc. It makes our angle vertex become, the opening become quite small. Even though the legs go out big, they cut more area of our circle. However, the vertex goes all the way down here and makes this opening smaller. So let's put our value in here. We know our arc measure. It's way out here. It's 118. We have 2 times our angle. We'll just call it angle is equal to our arc, which is 118. So we're going to just solve this. We can even change this to x if we want, just to make it look a little more like what we're used to, where x is our angle value. Divide both sides by 2. X equals 59. And then because we're looking for the measure, our answer is in degrees. This opens 59 degrees, and this, meaning that this is because we pulled it so far back, they're not the same. This is actually twice as big. So here we're looking at PS. We're looking for this arc here, PS. So we know that angle SRP is 27 degrees. So we can say the same thing. 2 times our angle, we now know it is 27 degrees, will equal our arc. So 2 times 27 is 54, equals the arc, the measure of PS. And because we're doing measure, we need to have degrees. So SU, so we're looking at SU here. So looking here, where is SU? So we're going to start at S. We're going to go to U, and we go the smallest way around. Because it's 2 letters, we know that that is a minor arc, so our answer should be less than 180 degrees. So we know that this one right here is 54 degrees, so we can say 118 plus 54 is equal to 172 degrees. 172 degrees, which makes sense. 2 letters, less than 180 degrees. So it's a little tricky. It might, to go from SRU would be how we would have to identify if we're going to go the longer route. All right. Find the measure of the missing angle. So here we have our quadrilateral, and this is where we're going to come into play. We have this formula, twice the angle equals the arc, but we're dealing with an angle. Here we're dealing with a quadrilateral. We could figure it out using the information, or we can use our shortcut that's given to us. And we're saying that these 2 angles are across from each other. So angle P and angle R are add to 180. So what does X and Y equal? We can say the same thing here, opposites. So angle Y is right here. We can say it's 180 minus 75 degrees, because angle P plus angle R is equal to 180 degrees. Angle P, we're going to substitute 75 degrees is in here. And then angle R, we can say is our Y. So our Y is equal to 180. Subtract 75 from both sides. Y equals 105 degrees. 105 degrees. So let's do the same thing up here. This one's a little easier. So this plus this should equal 180 degrees. If this is taking 80 of it, then this one has to be 100 degrees. 100 degrees. All right. So those are the quadrilaterals. So looking at problem number 10, we can pull in a lot of information from past learning in here since how we've done so much about this. We can take a look at this problem right here and use our properties of right triangles if we need to, or we can use all we've learned all year long about what a right triangle or any triangle is. It could possibly be isosceles or equilateral. These are all terms that we've been studying all year long. So let's take a look at what we have here. It says in the directions, find the following measures. Measures tells us degrees, and given that JK is the diameter of the circle. There's some key information right here. JK is the diameter. So I'm going to just put a little point on here to remind myself that this is the diameter. So first thing it asks us here is, what is the measure of JK? So we're looking at JK, which is right, starting at J, going to K, that measure right here. Well, we should see that because this is the diameter here, that this cuts our circle in half, and so JK must be 180 degrees. Must be 180 degrees. So what is the measure of JIK? This is an angle. This is where we have to watch our symbols quite closely. So we started our endpoints. Here's our endpoints that we have in here. Here's our endpoints. And we're going to go and follow JIK. So we have to keep in mind. So this is our endpoint. So if this is our arc is 180, then this is our inscribed angle right here. This is 90 degrees. So we can see that the 90, once we pull it back to the side, it's quite a bit smaller than if it were necessarily having a vertex at the center. We can use that information to be able to go all the way back. If we need it, we can say twice the angle equals the arc. Here we have the arc of 180, and you can see that 2 times something equals the arc, which is 90. All right, so now we have that. Now we need to look at what we have in here for KJI. We have this one right here. We have this KJI. And we know that this is here a angle. Well, we have our lovely triangle that we're looking at right here. So if we know that the measure of all the angles inside a triangle is always 180 degrees. So this will be 180 degrees minus 30, which is given to us, minus 90. Because this angle plus this angle plus this angle should all equal 180 degrees. So we can work our way backwards, which means that this is 60 degrees. 60 degrees. Now this is a line segment notification that we have on here. This is a line segment, and we want to know how long this line is right here. How long is this line? Well, that is where we're looking at in here are trig properties that we can have. Now we have anything with a right angle, with any angle that has a right angle in it, we can use our trig properties. So what we're looking at in here is we're going to be looking at, I'm going to pull that triangle out to the side here. And this is our right angle. So it's not super great, but I'm going to put our symbol in there so we can put things together. And then this tells us that this length is 10 inches. So, and then the other information that we have is 30. And then we figured out this one as 60. So I'm going to stick with the 30, which is given to us, because what if I made a mistake on the 60? I didn't, but what if I did? So I'm going to stick with what was given to me so that I don't make another mistake in here. So we have to do our A, H, and O. So we have to find our hypotenuse. Our hypotenuse is right here, which is the length that we're looking for. We're looking for the length of this line right here. That's our JK. We know that this one across from here is our O, and this one, last one, is our A. This is our opposite of our angle, and this one is adjacent, which means next to. So we aren't interested in the line segment that's next to us. We're interested in the line segment that's the hypotenuse, and we're given the opposite. So in our SOHCAHTOA, the one we're interested in is SO. So let's take a look at this. I'm going to put it over here so I have a little bit more room. The sine of the angle we used as our reference angle as 30 is equal to our opposite over our hypotenuse. So our opposite is 10 over our hypotenuse. The sine of 30, we're going to punch that into our calculator. Once we get that, that'll be 0.5 is equal to 10 over h, cross multiply. So we have 0.5h equals 10. Divide both sides by 0.5. H will equal 20. Because we're looking for a line segment, it's 20 inches. We have to use inches. It's not a measure, it's a length, so we're going to be using inches. All right, I believe that's the end of it. Here's the, where did it go? Here it is. Here are the U-tries that we're looking at in here. Here are your U-tries. And this is the back. Looking for these measures. So be sure if you're using this at home that you do the U-try so I can see that you've learned and that you're doing well and that you're ready to take the reassessment. Have a great day. Thanks.